I've travelled around the world, doing photography, experienced the cultures. He's won a few awards. He was taken in Zambia National Park. I worked as a senior technical ranger for mainland national parks and marine parks. Over 32 years I done a bit of compliance work, chasing poachers, doing experimental design, like to survey all the boundaries of the national parks, so that's the remotest area of a park around the boundaries. I've caught a few crocs in my day. My name's Nissan, I'm 68 years old. I've had Parkinson's disease for 14 years. It's progressively getting worse, probably exponentially. I haven't travelled for 4 years. It's something I've got to do. It's in my blood. I freeze, I can't walk. My muscles are stiff. Tremors 6 times a second I shake. I can't do my shoelaces up anymore, I can't put my shoes on anymore. I can't fish anymore. So I can't tie my bloody knots. Seems like a small thing, but it's a big thing to me. My facial expressions have changed. His muscles don't work and it's hard to communicate to people. He just looks sad all the time. People ask you what's wrong with you all the time. It's nothing, because my face is not working. I've trapped inside my body.
What happens in Parkinson's disease is cells in the brain which make dopamine start dying. And a lot of them die, and a result of that, you get stiffness, you get troubles moving, you get the tremor, all those things. But there's a lot of non-motor symptoms. So, people have they're anxious. There's all sorts of different things that go along with it.
You get bouts of depression because you don't have any of the feel-good hormones anymore. It's just got to a stage now, something's just got to be done. I want my life back.
The treatment for many, many years has been replacing the dopamine that is dying because the cells are dying, right? So you give people this compound called L-Dopa, and that works fine for a bunch of years, but then it stops working, or you need more and more of this levodopa, and that has its own issues, okay? So deep brain stimulation is a procedure in which electrodes are inserted into the brain and current is passed into the brain from a battery, a bit like a pacemaker, and that stimulates a bit of the brain, and what it does, it relieves the symptoms of Parkinson's. It doesn't cure them, okay? It just relieves those symptoms, but it means people can get on with their lives, okay? And DBS is something that Peter Silburn was one of the early pioneers of. Him and Terry Coyne have been treating patients for 20 years now.
It's a pretty strong tremor.
Just going to do a bit of testing, Jennifer, see if we can stop this bad tremor.
Go.
25. All right. See, we stopped it, eh? Pretty good spot. See, we stopped the electricity and the tremor comes back.
Good job, Brian. Good job.
Peter and Terry have all the clinical expertise, but in terms of trying to understand what's happening in the brains of these people, we have that kind of expertise because the brain is a complicated place. So we started a collaboration, and out of that came the Asia Pacific Centre for Neuromodulation. We are the biggest centre in Australia doing neuromodulation, and the aim of the centre is not just to treat people, but also to try and understand what's happening in this disease.
Hold it up there. Say ma ma, la la, p, t, k. Tingle gone?
Yeah.
Good job. The conditions that we can help are basically Parkinson's disease and tremor disorders, dystonia, Tourette's syndrome. We're doing trials in anorexia. We've completed one with obsessive compulsive disorder. And the big thing I think is that we're moving to treatment-resistant depression. Wherever there's a problem in the brain, we can find the target that may help it.
Neuromodulation treats what we call circuit disorders. So a lot of diseases are the brain structure is intact, but it doesn't function very well. So think of it like railway tracks around the brain. So There might be some problems where the signalling mechanism has gone a bit awry, and so the train's being sort of pushed onto the wrong track at the wrong time. And compared to neurodegenerative disease where the train tracks are sort of dissolving away, or someone having a head injury where the train tracks are violently removed, so when you look at it from the outside, the train tracks aren't there anymore. So that's probably the difference.
I'm apprehensive. Somebody's playing around with your brain, yeah, I'm a bit nervous. But it's right at the end of the tunnel for me. So it's something I just got to do now. I can't avoid it anymore. I need to be free again.
I've had symptoms of tremor for about 5 years, and it was recently diagnosed as essential tremor. So the tremor was in my head, my shoulder, both my arm, my leg. So it made life quite difficult. You know, I found I stopped going out, stopped doing things because of the tremor being so intense. And since the surgery, all that's eased off. I struggled with the symptoms, but I also struggled with the whole idea of brain surgery, whereas it turned out to be one of the easiest things I've done. It's probably not as bad as going to the dentist. It's pretty amazing.
At the Class 1 evidence level in top-tier medical journals of the world, clearly states that you do the deep brain stimulation sooner rather than later. Basically because it can reverse things in front of your eyes. So people may struggle with their symptoms, which impacts on their quality of life, and the DBS can turn that around virtually immediately. It's just like that. All those years of hacking it and the drugs, so you just get it done. You saw it stop in an instant. The drugs can go out, she doesn't need them anymore, and she's got choices back in her life.
It's funny because since I've had the surgery, I felt like almost a new lease of life. I've got so much I want to achieve, so I just booked a trip to New York. I'm doing all the things I want to do, going out lots, going back to dragon boating, been going out with the kids, been sailing. I've just started back dancing, which I'm loving. It's nice to have the shoes on again. I definitely feel like I've got my life back.
I think with Parkinson's, it makes you realise you're only human and you only have a certain amount of time. Get out there and just live a life again. People take life for granted too much. You get something like Parkinson's, it makes you appreciate what you've got. And you don't realise it until you lose it. My body at present is a jail. I want the key. DBS is the key, I think.
Morning.
How are you?
Good, mate. You in good form?
Yeah.
You set?
I'm set, I'm ready to go.
You're on a mission. You're on a mission now.
Yeah.
Good. With people with undergoing DBS, we have quite a just streamlined system. We have to make sure that the right person is having the right operation at the right time. So in our system, we basically have neurologists, neuropsychiatrists, neurosurgeon, we have the DBS clinical nurse specialists, we have general physicians involved.
You got those freezing there, and we'll walk over to the chair.
And there's an assessment process before we even say, okay, let's go.
Good job. Well done. Feel okay?
We know that many people with Parkinson's also have what we term non-motor symptoms, and these are conditions such as depression, anxiety, addiction, problems with memory and thinking clearly, and hallucinations. And my role as a psychiatrist here, working with people with Parkinson's, is to optimise those non-motor outcomes as well as the motor outcomes. So in people thinking about deep brain stimulation for Parkinson's, I would meet all of them prior to the surgery, and that's really to get an understanding of the nature of their illness, how it's affected them and their significant relationships, and whether they have already some of these non-motor symptoms. And it helps us as a team to plan their care more efficiently following the operation.
I'm looking forward to it now. Yeah, I just want to get my life back.
Here's Frank's brain here. So right now, this is step one. This is actually looking at the target. So in Parkinson's type situations, you'll aim in here. So the CT is geometrically accurate in space, 3D, and these are the coordinates we're going to use. Tom, left is first. AP is minus 11.8.
11.8.
Lateral is minus 12.7. And the vertical is minus 17.9.
17.
So now we've got visually where we're going to go. That little dot there, the target is where we want to put it is, say, 1 millimetre, so it's tiny. So it's now referenced to what the guys are going to do up here. Come, I'll show you. This frame here, everything in that dot that we saw, everything in that dot is now referenced to this. That was put on with the CT scan. So now we've got a platform that's geometrically accurate, that we can do this bit now. Come this way, we'll see what Chris is going to do.
That point of that pin there represents our virtual target inside the brain in 3 dimensions. So this is called a phantom frame. We put the X, Y and Z coordinates into this frame according to what we've seen on the computer. So the intended target and the real target match perfectly now, so we're happy to proceed and put the frame onto the patient.
Terry's job is to open it up safely and get the drill hole and give us access to the brain, and then the rest is shoom, shoom. So you'll see the actual probe go in. It takes about 2 seconds to get right to the middle of the brain, and then the next 5 millimetres can be half an hour just finding those individual brain cells.
So making progress, Frank. We're just checking out all these places that's the best spot.
We're staying away from the saltwater crocs. Why? Jasia.
The brain isn't completely firm and solid. It's relatively spongy, and a lot of the materials that we put down tend to part the spongy substance. So that's why doing this generally doesn't damage the brain. So a little bit, an analogy might be pushing a log through a big chunk of seaweed in the ocean. It'll just sort of go through and part all the structures. So it's certainly not causing damage to the brain. It's trying to restore damaged function back to normal.
First electrode that gets put in is an exploratory electrode, and that is to identify the target where the permanent lead is going to go. And the lead goes in, it does 2 things. One, it allows you to deliver current into the brain, and then you can stimulate and see if the tremor goes away.
Just relax your arm here, mate. I'm going to move your arm now.
1.5.
Just relax it, buddy. I've got it.
1.5.
I've got everything here, mate.
2.
Cut it.
2.5.
So you've taken all the stiffness out, mate,
1.
and then the tremor went with it.
1.5. Bottom contact gets through below.
And then that same electrode can be used to record from the brain while the patient is awake. So here's an opportunity to record activity in a human brain, okay, while the patient is awake and doing things, moving their arms and legs, asking questions.
Count backwards from 100, mate. Go. 199. You jumped one, mate. You went from 94 to 91. You're fudging on us.
Take the shortcut.
You took the shortcut. You could see on the screen those fence palings. Well, that's the individual neuron firing off. And that's, in this whole environment, you're seeing the electrical activity of one cell. Let's listen to them. That's the wrist, backwards, forwards. You're doing good, mate.
It is groundbreaking. Look, for many reasons, all right? Pick any disease you like, okay, including cancer or infectious disease. And the testing is done first in a laboratory, all right, in a dish. And then you do it in animal models, okay? But here's an opportunity to record from a human brain, right? And it's there not just because we're doing experiments, but it's part of a clinical procedure, right? And there's very few groups in the world who are capable of doing this.
So all those big cells were firing off and they were bunching, so that's causing the tremor. And then when we turned it on, the tremor stopped, then the rigidity went. So we know we're in a good spot, so we're happy with how it's gone now. But it kind of shows you the importance of having more than one thing to confirm you're in the target. More than just the images or the the neurons, but the clinical signs. So we can see the target, the clinical signs we're pretty well in it, yeah. So we're happy.
It's a whole team of people that are pretty well trained and pretty experienced, so there's lots of checks and balances in the system and everyone working together. We've sort of just ticked past our 1,200th patient. Certainly we've developed a system and a way of doing this over time, so on average it would be between 3 and 3.5 hours. So it is efficient, I think, even at a world level, like 6 to 8 hours would not be uncommon around the world. The time you take to do the surgery itself, it's not a critical step, it's critical to do it properly and probably is a little bit kinder to the patients. They'll be better off for it ultimately.
So what the boys are doing now is that microelectrode's out and they're putting the permanent lead in. Hey Frank, that went well. And I'm pleased to report that there were no kangaroos jumping out of the top paddock. Okay, mate. Sorry? Just go on. Drop bears. You did good, mate, all right? All that stuff went. You felt the tremor stop. Yeah. Good job. Good job.
So this is the battery, which is where the electrodes go into. So these will be attached to the brain leads, extension leads into the battery. So yeah, down behind the neck and then into the chest.
The original terminology is an implantable pulse generator because it delivers on average 130 pulses per second, and we adjust the strength of that, how much electricity is delivered and how long those pulses last for, in order to attenuate the symptoms that the patients might be experiencing. The longevity of the battery is roughly 3 to 5 years.
We start the programming straight away and you'll spend the night in intensive care and then the next morning back into the ward. The amazing thing about this stuff is tremor for so long and you saw it go like that. How good is this job? How good is this job? In the world, I think that we've been recorded as being in the top 5 in theatre proficiencies. So everything we do, the patient is at the top, it's underpinned by hardcore science. We have the core, but the Queensland Brain Institute at the University of Queensland, it's got neuroscientists in there who can analyse the signals that we get from someone's brain while they're thinking or meditating and learn about the circuits of the brain. The signal people, the software engineers then feed into other people who are looking at the neurobiology of these circuits in the brain. That's huge. There's not many places in the world that have got that. It's good old Queensland. And in fact, as an example, if you like, of what we've been able to achieve here was the ability to remotely program human brains. And it's kind of like a virtual clinic.
The doctors at the clinic decide what frequency and the split of the signal. And then with this device, I can actually change the strength. So if I'm stressed or if I'm exercising, I go up a little bit. That's been great.
Now, we can actually operate on people here, and we can send them back to their own homes and manage them thereafter, not just locally, but internationally. So we've been looking after people in Italy, France, Japan, Indonesia, Bali, Fiji, New Zealand, to name a few. What we achieved here in the proof of concept study was rapidly adopted around the world by the Food and Drug Administration of the US, Japan, I think called the CE mark in Europe, and the collaboration was recognised in Time magazine as being one of the top 100 all types of inventions in 2021. The thing that excites me the most with it, at a clinical level, just seeing people sorted. It's hard to explain that, because if you know them before it and you've been looking after them and you know they're hurting and they're worried about having this procedure, but you say, look, it's been around a long time, and you see something change immediately on the table, that's like very cool. There's just no two ways about that.
Before the surgery, I was a prisoner in my own body. The fact is that I couldn't walk. I was limited, my mobility was limited. Well, since the surgery, my shakes have virtually disappeared. My soreness in my muscles is gone, and the sniffs are a lot more flexible than I used to be. I can bend down and pick something off the floor. I couldn't do that before. I'm sleeping 6 hours instead of about 3. And the cramps, which was probably disrupting my sleep, have gone. All the different tones in the voice. It's not a flat monotone voice anymore. People are able to understand me a lot more. The things that I can do now that I couldn't do before are fishing, playing golf, driving. Those 3 things I don't shake at all now. My balance has improved considerably. In all, it's been a total improvement in everything, all aspects of my life, really. I found my happy place again. I've got too many plans at present. My caravan is my accommodation for when I go over to Western Australia to photograph wildflowers. In fact, I want to see virtually all of Australia again. Yeah, it's going to be my home for a year or 2. Since all these symptoms have gone, I just feel a normal person. I'm not a prisoner in my own body. I'm not a prisoner in the house. I'm not scared about what people think anymore. And I can do most things again. More independence, and once you get your independence back, you're a completely different person.
We're only scratching the surface of how the human brain works. And at the APCN, the Asia Pacific Centre for Neuromodulation, we're very cognizant of the fact that this is a unique opportunity that we have. Then we can learn and study the human brain and contribute to the knowledge in the future.
It's really the last frontier in biology. We believe that. And evolutionarily, we're meant to die at 50. And we used to, 200 years ago. And now most of us, because of good health care, good water and all those things, can live to be 90s. Along with that comes with the fact that many of us are going to get dementia. Lots of us will get Parkinson's disease, which is a neurodegenerative disorder. And for a lot of the disorders, the biggest predictor right now is age, right? And really, you need better treatments and better understanding. You need early diagnosis for Parkinson's, early diagnosis for dementia, so that you can get to people before they get the symptoms, all right? And that's what places like the QBI are setting out to do.